So we'll continue with the previous session. So far we know how we can obtain food, feed, different ingredients. So when you see the agri farm to fork system, raw material stabilization covered. Then we have a processing technology, some aspect of it, obviously not in entirety of having all the technologies, all the ingredients and everything. That's and then once you have ingredient, what comes next? Next one is how do you characterize it? So some of the characterization technique you have already discussed and seen it, FTIR and different one. Some of those basic ones you can look into any standard protocol for color, composition analysis or so. That is all is pretty much standard as per AOCS methods or as per AACC method. Different methods are already established. And then comes the product for packaging aspect of it. Yeah, that is also integral part of blue circular economy, both in terms of using the existing packaging material and bringing circular economy to it, or to develop a new polymeric material from the ingredients what we have already extracted. Yeah, how we can make circle. So that will be complete, value chain will be completed after this particular module. So that's this particular lecture. So first, what is the problem? We always start with the problem, then becomes easier to understand. So global plastic waste, we all know, you walk around any street, walk around any city, what you will see, plastics everywhere. Yeah. So there are lot of studies are there, lot of data is available, how much the plastic is generated annually and what is growth expected to, whether we go for biodegradable or compostable plastic or alternative packaging material, but whatever plastic is in use still is going to have usage and is going to increase because we are increasing number of food, population is increasing, requirements are increasing. Recycling, very less amount, less than 10% is recycled. So that means we use the same bag. In some places we started recycling and it is only because of enforcement. You have to pay 10 rupees to buy a plastic bag, so you take your own bag from home. Yeah, you've seen in all the shops. Or other one is environmental impact. So whatever plastic is landing up in environmental landfills. It takes ages to degrade that particular polymeric material. Some plastic is broken down, then it comes into the ecosystem in a form of bioplastics. Yeah. Then there are work is going on to remove those bioplastics. That has to be carried out because still whatever plastic is already there in the water, it is coming in some form or the other. So that's all. I am not going to go into different statistics. So you open any, even if you open any browser and just type in plastic problem, you will see 100 different reports, 100 different work carried out globally and talking about the same thing, that is how much is the plastic, what we do, how we change it, and a lot of work is being carried out even in different institutions as an alternative to packaging material. So life of plastics and greenhouse gas emissions associated with it, that's not only associated with the production of packaging material, but also disposal and what are the environmental problems happening. So how we get rid of plastics or how we can reduce it. It is not expected after this particular lecture that will solve the plastic problem, but at least we will be aware of what all is required and which direction to move forward. So when it comes to bioplastics, that is plastics in a form of biological origin, that is changing from plastic or chemical economy to bioeconomy, biological origin plastic. So if you will see number of different type of packaging material, polypropylene, PTT, PET, these are all in use. Yeah, polyethylene terephthalate, this is PET bottle. Yeah, that's a PET bottle. Polyethylene, PEF, polyamide. Now these all are one which are chemical origin. PLA coming from lactic acid, now extensively used, and lactic acid coming from dairy waste. Yeah, lactose to lactic acid and making it cyclic, that is PLA. Then you have polyhydroxy alkylanates, starch based, polybutylene and cellulose regenerated. So, a lot of different types of biopolymers are also growing at the moment, that is bio based, non biodegradable, that is they are bio based but they are non-biodegradable. So some of the terminologies are important to understand. One is compostable, that means you can compost it, biodegradable or non-biodegradable, yeah, which takes time, but not as much as what a plastic or fossil fuel based packaging material does, yeah. So utilization rate, again, high production utilization, industry operates average utilization 82%, nearly full capacity. That means whatever businesses are, there still not lot of business scope is there to grow those type of packaging material. And then different types of variations are available, and you can see easily how your utilization of this is happening in a production and unused capabilities. So that means we need to have more and more space to grow those type of bioplastic and to replace it. So one of the major factors is again the cost of producing those type of polymeric material. This is just setting up some of the scenes. So coming back to packaging aspect, one, to know what are the categories of plastics, yeah. Typical polymeric material, production, yeah, food packaging. So we are only concerned about the food side of it, and then what are different categories of food. So there are almost we can name number of different types of categories of food which are used for which are either packed or consumed in some form of the packaging, yeah. Then you have seen all these simple symbols on any other packaged product, yeah. Unfortunately, even the people who have a scientific background, we do not look into those ones, yeah. We eat it, we dump it, yeah, isn't it? So how many of you read all these ones? 1, 2, 3, 4, 5, 6, 7, 8. It is something like, you know, 50% offer, yeah, and bottom selected items, yeah. One socks they have 50% off, and rest all is a normal price, yeah. So those things are changed in some of the stores. By law, you have to put the minimum percentage what is there, not I won't say the cheating word, but I'll say to be having a clarity in a business, yeah. Minimum 5% off, 5 to 75% off. You have to be very clear. You go to the shop, it says 70% off, up to 70%. You go in, then you'll see what is the 70%. 2 shirts are there on 70%, rest all is on regular price, yeah. So some of you were there in shopping mall anyway other day, so you have seen that all the shops, they have big sale, and whosoever was not having a board, then nobody was going in, yeah. So that same way, when we see the label, very few people they see the labels. So now the things are recyclable, non-recyclable. So if they are properly segregated, then we can recycle those products. So that becomes very important. So you know how we can address the packaging problem by replacing it, or by informing correct practices, the best practices, so that it can be adopted whatever is required from the nature point of view. Now, so 10 most commonly plastic object found in the beaches. This is European beach, but you can see it everywhere, yeah. Bottles, that's one. Bags, yeah. Crisp or candies packet, toffees and all those packets, yeah. Very few. For smokers, food containers, balloon and balloon sticks, yeah. Cutleries, cotton buds, sanitary applications. So all those different types of products are available. You go in any beach, you go in Marina Beach or any of the beach, you will see all this type of packaging material. So how this can be reduced? By becoming a responsible consumer. So there are a lot of campaigns are there, how we can use it and how we can recycle it, yeah. I've seen even the container like waste bin is there 5 meters away, yeah, and people, they won't bother one step to walk and just to throw it into a bin, yeah. That's one aspect of it, right. We all are responsible. Even in this room, everybody is studying science, but still we do the same. So there is no point in arguing with the people who are uneducated, yeah. So that's one aspect, right. So, million tons of plastic generated dumped in ocean every year. So, what is the problem it causes? Even the garbage truck is throwing every plastic into oceans and natural water bodies. So, what is the challenge? What happens because of those plastics? Those plastics are consumed by animals and it goes to their stomach, and part of that goes into the product, and then you consume it. Yeah. So, that is the cycle of bioplastic. So, either how we remove the plastics from the water is one challenge. Other one is how do we remove the bioplastics from the product what we are going to consume. That is difficult. So, solution is, especially those who are consuming eating seafood products and all, should be more cautious at how this plastic is going into our own system. Yeah. So, that is what all these slides just shows what are the problems and how we can address those. First one is awareness. Yeah. More seeking a consumer products that are completely eco-friendly, but still many barriers are there for design and manufacturing side. Can you think what is the challenge why we are not able to replace conventional packaging material? What are the challenges replacing this plastic bottle? Or do you think every plastic can be replaced or every plastic should be replaced? Can be replaced? Answer is yes. Should we replace every plastic? Because some plastic can be recycled. Yeah. The problem is if it is properly recycled. Yeah. Some problems are when you have a duplicity of material. One base material is A type of plastic and cover is B type, that is PET plus LDPE. Yeah. Bottom tray is made up of A type of plastic and top film is made up of B type of plastic. Mixture. Same thing is with the textiles. Cotton easy to recycle. Cotton plus polyester. Yeah. Cotton plus nylon. How do we segregate it? Segregation is another key problem for recycling. Yeah. So, that is not a problem if food is attached to a packaging material, because that is an organic matter. It will be burnt at a lower temperature itself, will be gone into ashes, where a packaging material can be recycled. Yeah. So, that is one is to have awareness. Yeah. And there a lot of work is carried out in a social aspect of food, how we can raise awareness among people. How sustainable is the food packaging industry? So, we only focus on the food side of it, given our expertise and remit. Food industry must take a greater responsibility for single use plastics. Government tried to reduce the use of single use plastics. Nobody was listening. What they introduced? The law and put a fine. Yeah. So, because of that, people stopped using single use plastic. Now, slowly again it started coming in from hidden bags. Yeah. Nobody was supposed to have single use plastic, but in remote villages, in cities is okay, but remote villages still they are using it. Yeah. So, that is one how we get rid of single use plastic. Single use plastic means which cannot be recycled easily. There is small thin films, you go and buy a mango and you have single use plastic. Nobody want to carry the paper bag, or nobody want to carry the bags from their home to buy vegetables or crops. But nowadays slowly awareness is increasing. Now, this is one of the image coming from the Twitter. Yeah. There is a Kenya bans the use of single use plastic bags. Yeah. In India also it was banned. Are you aware of that? Single use plastics was banned. Most of the pan parag and all those small gutka packets which used to be everywhere, now those has been replaced with degradable one or bio based one. So, that is why you do not see those type of waste product that much on the street, because it degrades faster. Yeah. And then earlier 40 companies including Coca-Cola, Asda is a big retail company like a Tesco, signed up a UK plastic pact pledging to cut the plastic within 7 years by designing better product component. If you have seen one, somebody brought a box of chocolates from a country, there was a big box having a packaging, that is fine. Within that there was an individual packet packed again. Within that there were 4 pieces, each 4 packet was packed. Within that there was one another packing, and under that there was small piece of paper. Yeah. So, out of 1 kg, yeah, 300 gram was only the packaging material. Yeah. Right. If you buy a chips, what most of the time people will say in villages is, ah, they are selling the air. Yeah. You know that most of the potato crisp packet, there is some gas infused into it. You know what is that gas? Nitrogen. Why nitrogen? Anyone?
To avoid rancidity, sir.
Hmm?
To avoid rancidity and improve the shelf life, as well as it acts as a cushioning.
Avoid density, how? No, correct.
It's an inert gas.
Hmm?
It's an inert gas. So oxidative rancidity will
exactly.
be.
If you use a CO2, it will become rancid. Yeah. Okay. So that's one thing why we have to focus on this type of aspect, right? Yeah. So what are the main highlights related to that? First and foremost, that no packaging material should go to the landfill. Yeah. That's one thing. That is, no plastic. This is again European initiative, that no plastic should be there in a landfill. Sludge and all is okay, but eliminate unnecessary single-use plastics. 55% of plastic is recycled, reusable or compostable packaging bag by 2030, not 100%. And these are realistic figures which can be achieved. Yeah, that means whatever plastic we are using, how best we can recycle it. So nowadays one initiative has started, and Germany is one of the country which is recycles the most of the plastics. Yeah. If you have plastic bottle, it says R on it. When you finish drinking water, you go in the shopping mall, you put those plastic bottles and you get money out of it. And if you remember, in India this was done when people, they all keep the plastic bottles, glass bottles, newspapers, and you get a money, right? Yeah, that was already done. But now also it is done, but whereas when you buy any stuff, you pay for that one. Recycling cost is included in the product when you purchase it. So we were already doing it. Yeah. So it has intensity has to increase, and how we can recycle it. The person who buys all the plastic material, so that was we call it, what we call the word kabadi. Yeah. But he was doing much more environmental job. Yeah, rather than most of the people who are throwing it outside. Yeah. But within that, laminates and all those ones, you know, with high barrier properties, packaging materials are not the one which are recycled the most. Yeah. So though that we have to establish a mechanism, how do we recycle those. So elimination of non-recyclable component in all plastic material. See, the problem is not only for recycling the plastic, but the fillers are added. Some chemicals are added within that. That creates a problem. For example, PVC. PVC is not used for food packaging. Yeah. What is PVC stands for? Polyvinyl chloride, because of chlorine going into the product. This helps to build circular economy, life cycle assessment of plastic to accomplish waste minimization. That means how we can do the life cycle assessment from farm to fork, yeah, A, and how we do 3R, that is recycling, reduce, or recycle, reuse and reduce, right? Reduce, recycle and reuse. So 3Rs are there, right? So how we can do that within the packaging material. So what are the strategies how we can reduce the plastic? Green packaging. So start using green packaging material. Green color packaging packets, yeah? No. Green means eco, biodegradable or so, right? Example, have you seen this type of Tetra Pak made up of paper? Yeah? Even these type of paper cups, yeah? They have inside there is a coating, but they are paper cup, and the problem is the plastic lid which comes on top of it. But most of the places the plastic lid is made up of compostable ones. Costa and all those brands, they started using such material, but that's why their product is becoming quite expensive. Yeah. Reduce single-use plastic, promote reusable formats, promote design to optimize use and recycling. See, the problem is when you take a plastic bag, from home and go to the shop, people, they think of their prestige issue. Yeah, oh, I can buy it for 10 rupees. Yeah, that's the problem. Prestige is also another issue which has to be overcome. Yeah, a step forward towards circular economy. Yeah, you've seen people, they even buy a water bottle and they keep refilling the same bottle. Yeah, but because of prestige issue, no, I don't want to use the same water bottle. You want to buy a new water bottle so that it looks fancier. Yeah, but slowly the time is changing. If you're buying a new bottle, you are looked into a different way, not as rich or what you call the person who is having, who are well off. The people who are recycling, they are seen in a much better fashion. You see all the big businessmen, yeah, they don't spend too much of money on their, how they dress, what type of expensive clothing and all, right? T-shirt and a trouser, that is sufficient enough, right? So that's the intention and the way the society is moving forward. Now the solution is linear economy, correct? No. Linear economy was single line economy, right? This is again the repeat of the first or second or third lecture. Reuse economy, yeah. A step advancing from linear economy to reuse economy, that means you are just recycling it, yeah. And then now to circular economy. So that means you start making a circle. Linear, raw material production, use and waste. Reuse, raw material production, use, and then again reuse it. Lot of places we do use reuse. For example, the plastic trays which are used for transporting raw material, same type of trays are used again and again till the time they expire, yeah. Whereas circular economy, even if it is end of life, what happens after end of life, yeah. So that is again important, where we discuss some of the project where things are biodegraded and then how that can be broken down into individual component, can use for different applications. So what are the challenges when it comes to food packaging? So if we pack food product, instead of having a PET, if you pack it in LDPE, for example, yeah, if this water is packed in LDPE, what problem happens? PET is an engineered plastic, yeah. What happens if you pack water in paper container, yeah, or if you pack a food in a paper container as opposed to a plastic container? What are the challenges? Same challenges will stand when it comes to food packaging. First one is how we can reduce the food waste if we are not packing in a material which extends its shelf life, yeah. Second one is the food safety issues. Have you ever noticed when we put lipid product or oil or a pickle in LDPE packet, you see all the oils coming on top of it, yeah. Whereas when you put a water, it doesn't come out. Why it is so? Anyone? There are some people who are working on packaging, and especially those who are doing masters, they would have studied all this, yeah. Yeah. Say anything, that don't worry about that. Exam is already over, you won't lose marks. Yeah, good.
Migration of oil through the packaging material.
True. Migration, because it is polyethylene, LDPE full form is linear density polyethylene, yeah. It is long chain carbon polymer. So oil is also a carbon polymer. It diffuses one end, comes out the other, yeah. Whereas in PET bottle, oil doesn't come out because that's an engineered plastic, yeah. So that means their permeability becomes important. Whereas when you put a water, which is a smaller molecule, it doesn't come out because it's only vapor transmission rate is much different, yeah. So all those packaging material, whatever you use it for paper one or to replace plastic. So what the best important application here is how we solve the food safety issues, reducing the food waste, employing different technology and improving the shelf life, and also replacing the packaging. So packaging becomes very, very important for any of the processing system or ingredient technology we develop, yeah. If they have a higher amount of water vapor transmission rate, it becomes soggy, yeah. Talk about solid product itself. Instead of laminate, if you pack a cheese into a biodegradable packaging material, it will start spoiling because of their vibration, because of their migration rate. So how do we improve their barrier properties, Yeah. So, that is so. Now, coming back to the core one, these were all the problems. That is why I was going bit daily. What are the problem? What are the challenges? What are the solutions? So, that is literature is full of that. We all know the challenge, we all know the potential solution, but how do we achieve it? Before going into that, whether you make a product or ingredient, we pack into a specific type of packaging material. In the beginning, it was written 2 packaging materials, right? The 2 types of one is a packaging film. Yeah. Thin flexible layer of material used to wrap, cover product for protection, preservation and presentation. Yeah. Presentation, when you give a gift, looks good. Preservation, to avoid the barrier properties, yeah, as well as the protection. Yeah. Preservation against barrier properties for microorganisms and protection to the food, whether it is the structure of the product or protection against insect microorganisms or so. For food, pharmaceutical, consumer goods and electronics, we know all the food packaging materials are used for different purposes. So, there is nothing new in it. Plastic, aluminum foils, or now biodegradable material like cellulose or PLA. Yeah. So, chitin, chitosan films are also made. So, how we make a packaging film? Anybody, any one of you know how we make a packaging film? Or how many of you have made biodegradable polymer? Or have you seen in any lab how they make biodegradable polymeric material?
Generally, in laboratory scale, we used to go for casting method.
Solvent casting method.
Solvent casting method. Appropriate solvent chosen. Like in case of polylactic acid, we have to go for chloroform, which is a non-polar solvent. Like in case of chitin and chitosan, we have to go for polar compounds. Water or acidified water with 2 or 3% of acetic acid. On that we have to completely solubilize the chitin powder or PLA pellets in the appropriate solvent, and we have to pour it in some petri plates or some ceramic dish. After we have to let it be for some time. We have to let the solvent to evaporate completely, and we have to maintain the RH and other conditions and surrounding parameters. After that, we can peel off the packaging materials. It will be clear and good for use.
Okay. Now, when we are doing solvent casting, when you use a chloroform, it contains chlorine, isn't it?
Yes, sir.
What is the chloroform formula?
CHCl3.
CH?
Cl3.
CHCl3, right?
Yes.
So, again we avoided a PVC, and then if you make a casting film, that is only to demonstrate that films can be made. Yeah. There is a long story after that, is like how do you make into the film. Yeah. Think the unit operation what you mentioned is perfectly correct, whatever way films are made, right. But think what all the chemicals are used. Yeah. Once you make a film, how much area you need to dry it, and amount of packaging material used is already you have seen couple of 1000 tons of packaging material is used, right. So, how we make it at a commercial scale and to make it viable. Even though if you make a chitosan film or PLA film, still they have not the same properties what are there for the packaging material which we are trying to replace. Yeah. That is correct way of making a packaging film. There are multiple other methods, some you will see it over here. I have a very short video. Other than a sheet is a thicker and more rigid used material for sturdy products or components. Yeah. I will give you one very simple example. Have you seen, if you buy any of the toys, they have some of the thermocols, small balls are there made up of thermocols, right. So, how can we replace that? I gave that idea to one of the guy, and they thought, oh wow, that should be used easily. You make 2% xanthan gum or 2% alginate solution, yeah, infuse air into it and dry it. If you freeze dry it, then what will happen? You will get sponge balls, yeah, and that is an perfect alternative to plastic. That can be easily used when it comes to toys for kids, you know, when you use a foam, because they start consuming it. So, if you have biological origin, that makes things easier. You have seen xanthan gum, yeah. So, if you make a xanthan gum solution, it becomes very thick, and if you dry that one, it becomes very fluffy, yeah. That is one of the perfect one for using it for certain material. Obviously, it won't have that particular strength what you see it in thermocol, but thermocol can be replaced in such manner. We were able to replace refrigerants, chlorofluorocarbons with new refrigerants. So, same way all these packaging material can be replaced by looking at the logic how and what are the biomass and how it can be replaced. Previously all the equipments were coming in with the straws, yeah, all the straw and everything was used. Now we replaced it with polyurethane, that means your expandable foams like chemical foams. So, how those things can be replaced by using this type of plastic. And other alternative is whatever the plastic material is, how we can recycle it and where we can use it. Yeah, we can use it for the places which remains there forever. Yeah, like electric pole made up of steel or wood. Yeah, if those are made up of single metal and covered with the plastic, all the recycled plastic, that's another one. It will be shock proofer. So, there are number of places how things are getting replaced slowly and changing stuff. Yeah. So, that's and the sheet is, so this is a packaging film and a sheet. So, what is the difference between film and a sheet? Thickness, flexible and pliable, wrapping, lamination, sealing, food packaging, shrink wrap, like when you do vacuum packing and all those stuff. Plastic metals or biodegradable, it can be even a plastic. What type of metal? Example, aluminum foil, yeah, or biodegradable material. Often comes in a roll, you know, packaging roll, you know, it's a thin film, we put it around the food and sell it in a market, and everywhere you will see it. Sheet, thicker, flexible, structural, plastic, metal or glass sheet, typically sold in a flat sheet or in form of panels. Yeah. So, these are all what you can find easily in a textbook. So, what are the proposed solution as of today? One is bioplastics. Yeah. I did not write a word here biofilm or biosheet to avoid confusion with biofilm what we studied other day. Yeah. The plastics derived from renewable biomass like corn starch, sugarcane. Are you aware of any other bioplastic which has been used to date or been proposed or work is carried out? Any other? Alginates, chitosan, they are there. So, will eco-friendly, lower carbon footprint and biodegradable option. That means you are not exporting and transporting film from one place to another one, and then to recycling, that is lowering carbon footprint. That means you are not keep buying a new and new. So, that means recycling becomes an important integral part of it. Versatile application can replace conventional plastic in packaging, agriculture and more. That means you can use it for different applications. Yeah. Benefits we all know. Sustainability, we reduce waste of the plastic by using biodegradable or compostable options. Circular economy, supporting recycling and reuse. Yeah. And reduction is eliminated from here because that comes into sustainability part of it, right. Consumer preference, growing demand for green packaging, but only for those consumer who are bit more environment cautious. Yeah. They are not, they put environment first, economy second. Those who could put economy first, environment second, for them consumer preference is different. Yeah. How many of you read a label made from recycled packaging? How many of you read label that packaging is compostable packaging material, an expensive product? €1 burger or €1 samosa packed in a plastic, or not €1, sorry, 100 rupee samosa packed in LDPE, or 150 rupee samosa packed in biodegradable compostable film. You will go for 100 rupees. Yeah. So, till the time consumer mentality is changed. So, that is why to change the perception of consumer, you instigate media and other places to solve that type of issues. Yeah. So, that is why these are the four key benefits and of using it. Nowadays certain products are having premium prices just because they have environmental credentials attached to it. Now, how do we prepare film? One is by solvent casting method, as your colleague mentioned how we use solvent casting. You have a biomaterial, You add a plasticizer, you add a solvent, you spread it, yeah. Remove the solvent, leave it for drying, either on a phosphoric system drying, or just normal hot air drying, or just leave it in environment, and then you get film. Other one is by using extrusion. The same extruder what you saw in making food and a feed is also used for making film. And other one is, I never named this one. What do you think of this? Heating, pre-stretching, mold on, vacuum on. This is one of the form called thermoforms. How many of you have seen the wooden spoons, yeah, wooden plates or leaf plates? So that is made up of leaves. Very nice sturdy plates are made, obviously depending upon how they've been stitched by hand or by using a glue or so. Very same residue, leftover biomass, can be used straight for making these type of packaging materials, yeah, and they can be very sturdy as well. There was some bit of work was carried out to make the plastic block as hard as anything by using mushroom mycelium. You have a biomass, yeah, add mycelium, and that mycelium is added into preformed container, allow it to grow, and it forms the whole space with the mycelium. Take it out, you dry it, it will be as hard as a stone, yeah. Though it will be water soluble, but remember that will be water soluble only at very high temperature or more exposure to water, yeah. So that type of material can be used for replacing plastics in chairs and otherwise making those building blocks, yeah. So this is the way how we can replace those type of material which can create environmental issues. So this is basically a thermoform, collectively thermoform, and whatever residue is left over, you heat it, give a shape, dry it. Do simple thing by get a starch or a soup mix or even a rice slurry, you dry it, it becomes like a stone. Same way you can cast it. So either you stretch it after heating, and if seaweed is used, if you go again, lot of companies started using seaweed as a seaweed leather, seaweed as a packaging material. Lot of different businesses are already started. Clothing material made up of biodegradable packaging material. There is one of those biodegradable packaging material is used in, there was a problem from one of the country in China, or one of the city in China, where you go in a specific type of clothes, and when you go to that particular place, you have to leave your clothes and come back. Lot of places in temples we do the same, yeah. If those type of clothes are made up of biodegradable packaging material and then goes over there, and then you discard it, so it will degrade on its own, rather than you don't have to have a disposal problem. So we have to see where all we can use it. To your surprise, in most of the hospitals in Ireland, they removed plastics altogether. Everything from lab coat to the containers, everything gone as a biodegradable. Packaging plates, packaging spoons, no plastic, because there is not requirement, you know, it's only for serving food, you don't need a metal plate, and it solves the problem of contamination, washing and all those things. Single use, paper plates, person eats, puts in a bin, and then you use it for your bioenergy part of it, because it's having biodegradable packaging material. So all these things can be used for a niche applications. Parties, you know, like we all get paper spoon and plastic spoons, instead of plastic spoon, paper spoon to drink this. Most of the straws, plastic is gone. Only in remote villages you will see still the same plastic straw. Every other place you will see the paper straw. Nothing wrong in that one, because you use it only once, yeah. So that's again by heating, by pre-stretching, mold on, vacuum on, different way how you can make that type of container, and they are pretty much successful as well in using those. So how we make a packaging film, this is a detailed description of this here and the next few slides, and then followed by a video. Selection of a biopolymer, that's first and foremost. Second, preparation of biopolymer and solution, that is again your solvent, correct. Incorporation of additives, mixing so that you have uniform distribution of it, casting, pouring or spreading, peeling, conditioning, yeah. you characterize it and then you store it. Yeah, this is the way how you make a film by solvent casting method. Yeah. So, I am not going to go into the detail of it. Yeah, it's like too wordy, but important thing: selection, starch, chitosan, alginate, gelatin, PLA or any other biomaterial. Almost every biomaterial which is having a larger molecular weight can be used for that purpose. Yeah. Higher molecular weight protein can also be used for making the film, but you need a larger molecular weight. That is the reason why PLA, lactic acid is smaller molecular weight, yeah, within 150 to 200. But PLA, that means poly, that means you make a lactic acid combined together to have a larger biomass. So, large molecular weight compound can be used for making polymer. Then you get a solution, chitosan in acidic solution, acetic acid, yeah. Again, when you are making biopolymer, so you eliminate the usage of chemicals as well. So, chitin, acetic acid soluble. Gelatin, we did discuss for the fish, that is again soluble in gelatinous material. And some places big fish which are harvested, their scales are removed on the beach, the big scales, and these scales are used directly for making lot of I keep missing the word, ornamental ones, or my making lamp shades, another one. So, those are the material which can again be used for a plastic. Yeah, and then starch, heat and dissolve in a water. So, depending upon the biopolymer, you prepare a solution. Then you add additives, glycerol, sorbitol and different to improve the flexibility of it. Yeah. Then other additives, antimicrobial colorant depending upon the need. Some films were prepared by one of the creative person where added microalgae at different strength coming from non-food application to color the film, because most of the biopolymeric films, they are brownish and the color are not transparent, to make it green, blue and different color packaging material, right. Mixing and then you cast it. Yeah. So, this is method is modified based on the conventional casting method what you exactly mentioned about solvent casting, and to eliminate all those chemicals, because the question were asked, that is very good, you are making a biopolymeric film from chitosan, but still using those chemicals which are not green. Yeah. Then you dry it, whether in drying oven or any specific chamber with slow drying, followed by solvent evaporation, then you peel and you condition it. Yeah. It's how many of you have seen conditioning of potatoes and onions? When we harvest a potato, at times the potato is left in a field and only the shoots are dismantled. Yeah. Or even onion, when you are about to harvest, you press all the onions, plants, you just crush it so that it is still attached to the tuber, but it is there, is completely crushed, just because so that the peel of that is completely conditioned and become hardened. Yeah. That is why you see when you buy a potato, you just rub it, peel is gone. Some potato you have to use a peeler. So, that is all the conditioning is also carried out in these type of film, because of environment and all, its strength changes. Then what you do once you make a film, you characterize it. Yeah. Without characterization, without looking its property, you cannot suggest for alternative for existing packaging material. Yeah. Majority of this biopolymer, they have very bad water barrier properties. So, where we can use them? If you buy a noodle pack, yeah, if you buy a noodle packet ready to eat cup and noodle, you will see there is small sachet inside, yeah, having oil in it, olive oil or some masala. So, if you use that particular with the biodegradable packaging material, if it is sealed properly, the moment you add water, that packaging material will be dissolved, then you can consume along with it, right. So, whether it is a starch or chitosan, that is fine. Yeah. Then again comes in with the origin of the ingredient. Yeah. So, that is one is solvent casting. Now, you see this particular film, how it is casted. Yeah. This is made up of, and he is a former master student of this place and doing PhD over there. Yeah. So, you'll see it simple mixing, yeah. This is chitosan and film is made and you get completely transparent film, yeah. It's as simple as that. This is only to show how you can make that particular film by solvent casting method, yeah. So, rest your colleague explained and I went through all the description. Now you see this is a solvent casting method by using a carrageenan and pectin. Pectin from apple pomace, and this is the already gone as an IP, and we already made a film with extrusion and all, which you will see in coming slide, yeah. So, this is a film made up of combination of pectin and carrageenan, and here the carrageenan was obtained from Chondrus crispus, and that particular carrageenan was not purified. Advantage we had with the calcium and the sodium and all those minerals present in that particular carrageenan blended with the pectin made the best film having a very good properties, and then shelf life studies were carried out on a specific product, yeah. Initially we presumed that this will have large amount of like very bad water barrier properties, and the sealability was an issue, but sealability can be sorted out by using some other technique, and then you can store this is oil, bread or a biscuit, yeah. Even if you consume along with the packaging material is perfect, yeah. So, this is a clear cut example by using a solvent casting, and the solvent used here is acetic acid, yeah, that is again eco one. So, that means completely green. Now, sorry, second one is compounding and making your film casting. Biopolymer, plasticizer added, natural plasticizer, mixing, soaking, cross linking agent. There are certain time you add cross linking to improve the barrier properties and strength, blending, compounding using twin screw extruder to make a pellet. In order to make a big films, what you need is pellets. Pellet is very important to make it before making a film, yeah. It is not always you take a dry powder, mix it and add a solvent, then dry it. So, again lot of water, so you have to make a pellet for making film. How many of you have seen how these PET bottles are made or how these LDPE packaging materials are made? You just buy those pellets, the round color pellets of any plastic material that is heated up in a liquid form, and then they are just casted, yeah, whether by making a film or so, and you get preformed bottles of thick sheets, and then you blow in a water, that is injection, blow hot air, and you give any shape whatever you want, yeah. So, the cap of the bottle, what you see the top of the cap of the bottle, the same thickness of the material is at the bottom. You put a dye and blow a hot air into it, and it takes that shape. Same way big drums are made, same way big sheets are made. That is the difference between films and a sheet. And then you cast by extrusion. Here again same biopolymer, plasticizer, mixing biopolymer and plasticizer depending upon what type of properties you need, you alter it, and then mixing biopolymer plasticizer with different blenders, soaking and hydration if it is necessary, and then cross linking agent to cross link so that you have a better properties. And what type of agents to be used, that is important. In some cases urea is there with nitrogen, glutaraldehyde, or certain natural cross linking agents are used depending upon where you are going to use that particular packaging material. So, if you will see this video, this is just extruder setting. I will just go through this one first. Compounding a plastic biopolymer, preparing the pellet, drying the pellet, and then goes for film, and these films are all made from seaweed ones. I have not put examples from other applications. There are a lot of other biomasses, starch and all can be made, and you will see lot literature on it. And then this is a sort of extruder to make a pellet, yeah. This is having a different temperature zone, and this what you will see, I am muting it because in the last somebody will say hato, and then you see these are the pellets which are made, yeah. So, these are the pellet made up of those particular bead, and these pellets are the one which are used for making film by extrusion. You can see different cooling system, and this is the commercially how these pellets are made by using extruder. Yeah. So, we will see once again, you will see over here where the pellets were, sorry, it was somewhere, yeah, somewhere here. You will see all these pellets are collected here. That means the string is made something like an extruded snack, and then you just cut it, so it makes round pellet or squared pellet. So, this is pelletization. So, examples: blending of pectin with different polymeric material, temperature profile 90, 90, 90, 90, 90, 90, 85. Yeah. So, these are different temperature profiles are set depending upon the material. So, if you are making a pellet from complete plastic material, these temperature is bit higher to make a pellet. Yeah. So, same way recycling, all these plastic material can be melted and then to make a pellet and then to make a film again. Yeah. Recycling does not mean that you use the same bottle again and again, that is reuse. Yeah. Recycling, if you remember when we are talking about recycling, upcycling and downcycling, we said to create a material of similar or lower properties. So, this bottle is melted, something like a wax in all the wax candle leftover biomass, you just melt everything and then make your own candle. Yeah. Very similar way, this plastic is melted with higher different temperature profile, made into a string, and is just chopped, and that plastic can be used to make a film or a sheet. Yeah. Now, film casting, how you make a film. Now, here you see this is all these film rolls are prepared from biodegradable packaging material. This is a video, I will run it in a minute. Load the melt extruded biopolymer, that means all those pellet and bioplastic component into the extruder for making a film. Yeah. Then you set up your screw speed, heating zone, and these are the one which has to be optimized. Yeah. It is not just there is single temperature profile for all the plastic. You make a film, you cool it, and you collect and do final adjustment. If you will see over here, because I hate describing the methods, to me it becomes very boring. So, that is why if you will see the video, this is the way the films and sheets are made. If you see, these are two different component, as I said, we made it from two different mixtures. Making the pellets here, one side is a pectin pellet, another side is a carrageenan pellet over here. These two are extruded through in a form of material and then goes to sheeting. Yeah, and you make a sheet rolls. So, this is an pilot scale unit to prove the concept to make a film, and then this roll can be as big as we want and larger volume. So, you make a film. Yeah. So, it is not that complicated to make. In my opinion, making a film by using a solvent casting method is more challenging in a lab than in a larger scale. Yeah. Do you agree by seeing this too? Yeah. You have to mix it and then you have to blend it and pour it and then leave it for drying, and even if it is not uniform pouring is there, everything becomes difficult. So, over here it is very simple. So, you make a pellet and then to cast a film and then you move forward. Yeah. Now, this is another one. So, this is same way how we can make a full film string, pellets done. This is pellet and then to use it to make film. Yeah. Is it done carried out by Manzural, who did masters MTech from here, and he just, you know him, yeah, and he just finished his PhD and going to continue over there. So, that is the way we made a film, and this is IP which has been protected with the formulation of pectin from apple pomace plus carrageenan. Yeah, and that film is perfect. Even if you eat it, that's fine. You are getting your polysaccharides into your consumption system. Yeah, and the chemical used all are greener. There are no chemical used which cannot be consumed. Yeah. Now, again, this is the properties. I will quickly go through these. One is your first and foremost is the tensile strength. Yeah, how much strength it's having. Elastic modulus. Yeah, that is maximum stress that can withstand while stretching before it breaks. Yeah. Second one, elasticity, stiffness of a material, how flexible it can be or how elastic it is. Elongation at break. Yeah. That means at breaking point, to which material can stretch before it breaks a percentage of its original length. Yeah. Flexural strength, ability of material to resist deformation upon bending. Yeah. If you are putting any material into it, if you blend it, it should not be the packaging material, should crack. Yeah. So, that is all related to characterization of film. Impact resistance, if you are giving an impact, how resistant it is, and all these are compared against conventional packaging material. Thickness of the film. Yeah. Tear strength, how much strength it needs to tear it apart. Barrier properties, how strong its barrier properties against water and oil and other nutrients. Antimicrobial efficacy. Now, very same film we added laminarin and a fucoidin and to see antimicrobial properties and to see how these fucoidin or laminarin or any antimicrobial agent can penetrate into the product. Take for example, if you have rosemary extract or any bioactive extract incorporated into, or a garlic extract is incorporated into these films, and you pack your butter or a cheese. Yeah. Over time, some of those natural antimicrobial will come into the product and product will have that ingredient which can be used directly for consumption. Yeah. That is ready to prepare, ready to eat product, then you do not have to add those flavoring agent. Yeah. Or coloring agent. Then you have antimicrobial. Antimicrobial, there are some standard methods, that is minimum inhibitory concentration required, and in order to test those concentration you have to do a test by using a model food solution. For example, you take a film and if you are trying to use it in a product whose pH is 3.5, you make a model food, add that film and see how much bioactive has gone into that model food. Yeah. So, all these area how we make antimicrobial capacity of the film, that is again the release rate, you measure release kinetics and all those element and strength of packaging material. Now, this is again important, biodegradability. How do we study biodegradability? Yeah. That we bury it in a soil or in a specific lab to say how long will it take to completely degrade. Yeah. That is also important if you are using microbial degradation to make biofertilizer out of those films. Yeah. So, one of the challenging project what we have at the moment, how we can use the film for biodegradation. There is a company that is called, you can look into them on on a website. They make, they have a system where they have their own microbial culture to make biofertilizer. The problem with the biofertilizer is if you are using any material into it, the microbial load of that biofertilizer may disturb the ecosystem or microbiome of a soil, and that microorganism can also impact the microbial profile of that particular food product. Some of the E. coli which comes from an environment, some E. coli comes from the dirty water usage, that is also another issue. Yeah. So, in order to do that, all the biodegradable material used in hospitals, the chances of clinical microorganisms or harmful microorganisms is huge. So, what was done, we use plasma technologies to inactivate that microorganisms at the biomass level, raw material. Then the biofertilizer what we obtain, there also we use a plasma so that there is no microbial profile, and in doing so some of the nitrogen level is added into that biofertilizer, because hospitals, even though they were using everything biodegradable, but still they were incinerating it because of all those clinical pathogenic microorganisms which may be there attached with hospital waste. Yeah. So, how we can use the technology to introduce circularity. Yeah. So, this is one. And then standard test method to determine anaerobic biodegradation of plastic material using a controlled composting. So, the experiments or research is not only going on biodegradation of the polymeric material or biodegradable material, but also on existing plastic, how we can degrade LDPE at much faster rate. Yeah, we will have to see one of those Japanese patent and research carried out on using a specific type of insect which consumes plastic. That was to do with the beeswax. Waxes, the beeswax, the insect which consumes beeswax can also consume some of those LDPE or plastic material. But the challenge there is it might create a bioplastic if it is not completely digested. There could be a way how we can improve, or you can use the microorganisms to degrade normal polyethylene or LDPE, HDPE or all those type of plastic material. That is also one area how we use a technology to reduce it, to degrade it, or to make it into monomer, and that monomer can be reused directly. Yeah, that is another way. Same biodegradable film, the moment we added it into ultrasonic system, gave a blast of it, and everything was fractured back into the starch and other plasticizers. That is another way of, instead of degrading it, you can reuse the same biopolymer. That is, once you make a packaging material, pack the food product, and how that biodegradable or compostable material can be reused again. Yeah. So, incubation conditions, CO2, O2 monitoring, airflow, moisture composting condition, and you record how it is biodegradable. Yeah. That, and then based on that you decide what is the best polymeric material or biodegradable packaging material. So, another area of research, when you make a solvent casting method, do the biodegradation study or compostable study to prove that point. So far majority of the research activity stops at the making a film and analyzing the property. Yeah. Then if you make a film or get those biodegradable film and do the composting of it to see what is the composting condition required, so that you quickly degrade them, or can we reuse those type of, that is reverse engineering, how that film is prepared, get the ingredient, and then those ingredients can be used again. Yeah. Any questions so far? Okay. Now we will see simple case study how it is made in a simple drawing and a story. Yeah. And then you get pectin sodium alginate. Even alginate was used, but the best film what we obtained was a carrageenan, and we got a good amount of protein also from Chondrus crispus. Yeah. And this is making from pectin and sodium alginate film, and all these calciums and calcium chloride used mainly for cross linking. And where did you get this calcium chloride? In chitosan production. Yeah. By using HCl. Yeah, calcium chloride, and that is one of those cross linking ones, so improve the strength of the material. Yeah. And same thing can also be casted with extruder. Now this is one of those crux how we can use a chitosan for making a film. Chitin, deacetylization, we make chitosan. Yeah. You got the chitosan, chitosan in demonstration. Once chitosan is there, either you use a solvent casting method, what you have seen it, or you use the extrusion system. You have seen that extrusion, melt processing, that means all the chitosan melted in a form of specific polymer, you add whatever additives you want, make a bead, and then you extrude the film, make using this particular extrusion method, and then you analyze all the properties. Thermal properties, how do we analyze it? Dinesh Singh Chauhan, DSC, yeah, correct, and TGA, yeah, all those technologies are used. Barrier properties, mechanical properties, rheological properties, that is again rheology is not that viscosity and all, other rheological properties, surface, antioxidant, antimicrobial, and then you do shelf life studies on a food product before you propose it can be used. Yeah. So if you use a chitosan film for seafood, perfect. Animal origin or marine origin goes to the marine origin. Yeah. Starch for starch product. Yeah. If suppose there are some reservation on the social side of it. Yeah. So this is how we can make film. Once film is made, what is the next? how do we pack it? Yeah. So, some of those equipment you would have seen it, yeah, in if you would have visited any of the factory. This is the most common one which is there in every lab, that is can sealer, yeah, made of tin, you make a can, that's fine. An internal coating is made up of specific material to avoid detinning and different effects. So, can is commonly used. One is automatic tray sealer. So, the problem comes in these type of tray sealer if the bottom material is made up of PET or polypropylene and the top one is LDPE. So, recyclability becomes challenging. Yeah. So, if we have a bottom plate of polypropylene as is and the top film is made up of biodegradable packaging film, yeah, it solves the problem. Yeah. So, then you do not have to segregate it, one will degrade on its own and other one can be recycled. Yeah. And then is semi-automatic fill seal machine, that is small cups, you know, you get small cups for having chutney and sauce and all. So, these are again filling machine. This is the thermoformer what I was talking about. That means by using a pressure you can make these type of cups or thermoformers. Vertical filling machine, have you heard about FFS, form, fill and seal machine? It is very similar to that one where you can control the portion of it, ingredients, products, whatever you obtain. Horizontal flow wrapping machine, yeah, this is just an example. We have all those ones to test the packaging material, normal packaging material as well as biodegradable packaging material. And this is semi-automatic tray sealer. As you can see, this is a simple tray and then you put a film on top of it and seal it, yeah, and then you measure also the sealing strength and other stuff. Yeah. So, these are different types of packaging material which can be used, but do remember you have seen this type of egg boxes. Now, most of those now plastic has come up, but the cardboard packaging material, compostable and biodegradable. Remember these two words and these two symbols which are used for these two type of packaging material. Yeah, I know you are not going to give any exams, but this is important to know what symbol is used for what purpose. Yeah. Dosing system, extruder you have seen just now, large scale extruder, and very same extruder was used to make alternative protein. Yeah. And this is also the extruder to make pellet. For extrusion melt one, you have first to make a pellet and then to make a film. Yeah. And extrusion technology remains the same, where you use it for making alternative snacks or protein or to make polymeric materials. Yeah. The only problem is if you are using it for polymeric material, then to move on to the food, cleaning is a big issue, because plastics are melted at high temperature, whereas food is at lower temperature. So, that cleaning becomes an issue. So, that is these are some of the equipment which are associated with packaging. And then extrusion system, you have already seen the video related to this. How do we do it? This could have 2 arms or 3 arms, A ingredient, B ingredient, 3 ingredient, all they need a different melting profile or melting temperature. If they do not need, that is fine. Oops, they are mixed together with the temperature zone and you make a pellets. Yeah. And then you can just control whatever temperature you need it, and then once you get a pellet goes into this particular hopper just like a flour, and then you make a film, or you use different type of film casting machines. Any question related to packaging and some of the properties? What I did not cover, how do you analyze all those ingredients, proteins and all those things? You are very well aware of it, and you are also very well aware that you have done some of those demonstration with NMR and FTIR and those equipment. Yeah. So, we remember one thing, raw material. Yeah. How do we stabilize it? Processing technologies to obtain ingredients, yeah, or what a horrible writing it is, ingredients, food or feed, yeah. Once you obtain these ingredient, or I will put it as a biopolymer, that is packaging material, and then you use this packaging material to pack those product and then product is finished. Yeah. So we'll have one lecture is on co-creation. When you make a product, how you involve people. It is not that you cook a food or I cook a food, I say eat, it's very good for you. The product has to be prepared based on consumer requirement. Yeah. We'll cover that, and then will be the now onwards will be all soft skills. So all this heavy duty text and processes will be gone, and if you have any question, just have a note of it and we can discuss it again. Yeah.